Good morning. So today we are going to discuss about the PN diode and its application. In the previous lecture, we have discussed about the forward bias and the reverse bias of the junction. Today we are going to discuss about how the PN diode can be used in various applications. So generally we have seen that P and N, the two are the semiconductors which are being made by joining p-type and n-type semiconductors. So we have seen during forward bias, the positive is connected to p-type and negative is connected to n-type of the semiconductor. And during that we have seen the depletion layer gets reduced, and we have seen the current flows like this way when the graph is drawn between V and I. So this kind of graph comes out to be there. So up to certain voltage there is no current because the barrier voltage is required to overcome it. After that the current rises at a voltage called as the knee voltage. At knee voltage the current rises sharply. So that will cause the diffusion flow of current to takes place. But in the reverse bias, the depletion layer, the reverse thing happens. In the reverse bias, we connect P with the N type and N with the P type, N with the positive. This is P type, this is N type, and P type with the negative terminal, N type with the positive terminals. They are being connected with each other. But during this reverse bias, the depletion layer gets widened up, so which may causes the further end diffusion and of electrons and holes to be stopped. If whatever the voltage you are going to apply, no flow of current is going to be there, and very small flow current is there, and that is due to the magnetic area. So that is a function of the diode, that it forward bias it conducts, and in the reverse bias it does not conducts. So we generally represent this diode by a symbol like this way, that is P type and N type symbol. Now the problem arises how we can use it. Now major part is the application part where we can able to use it. So one of the major application is that we can use it as a switch. Switch means on and off, on or off. So just like in an on and switch, we are using either we can on it or it off it. So we have seen in the forward bias the diode conducts, and in the reverse bias it does not conducts. So forward bias we can call it as on, and reverse bias we will call it as off. So wherever we want to use this diode as a switch, we can able to use them because it works like a switch. Another interesting application is that it can act like a rectifier. Now rectifier is a device which used to convert AC into DC form. AC into DC. So AC voltage to DC voltage can be converted by with the help of a rectifiers. So there are basically different kind of rectifiers which can be get used. One of the most important rectifier is the half wave and full wave rectifier, which we are going to discuss according to syllabus point. So first of all, what is half wave rectifier? Half wave rectifier is a device which rectify only the half of the signal. This signal is coming out to be there, it rectify only the either one half of the signal. So that is a half wave rectifier. Then there is a full wave rectifier, which rectify the full wave of the signal. Both signals will be get rectified like this way. So both of the signals get rectified. Now, which helps in converting AC into DC. So these are the basic devices. Now let us discuss the diagram for the half wave rectifier. How do half wave rectifier looks like to be? So let us start with this one. We have got a device and then we apply it. This is a coils of the transformer, and then we apply it a diode, and then there is a load resistance from where we can able to measure the output, V output. So this is the supply which is being given to transformer. So the either it conduct or transformer basically transfer the supply from one part to the another. This is the primary part, this is the secondary part of the transformer. As soon as the supply comes out to be there, Now, depending on the kind of supply, for example, if the positive cycle is coming out to be there, so positive and positive will be forward bias, it will conduct the signal and the output will come out to be there. And as soon as the signal shift to negative cycle, negative and positive, they will be become a reverse bias, no current will be there. So let us say we plot the graph, these are the inputs, and then after passing through the diode, what will be the output. So so let us say these kind of signals are there, which are being attached to the applied to the diode. During the positive half, signal will pass. So when you plot the graph, so the positive signal will come out to be there. But during reverse bias, no signal will be conducted, so no signal will be there. Again, then there is a positive signal, again forward biasing will be there, and then no signal will be there. So that means only half of the signal is going to be rectified. So that is the function of the half wave rectifier. So this half wave rectifier has a disadvantage that the it rectify only half of the signal. That is the main disadvantage, and it contains output contains a lot of ripples. That is the main problem with the half wave rectifier. So then we will switch on to the another rectifier that is called as a full wave rectifier, that is centrally tapped full wave rectifier. Next is full wave rectifier. Now, center tapped full wave rectifier, how to draw this diagram. Now let us draw this diagram. This is a transformer, and then this is a secondary of the coil, and then we attach one end of the transformer diode to this one, and second diode to this one. This are being connected. Now another, at the center, the transformer is being tapped out, and the output is being given, and then it is being connected with the load resistance, and that is called as RL. So where you can measure the output. Now the central tapped, as soon as the AC is switched on, the ends A and B become positive and negative. Now which ends A and B becomes positive and negative? Because during the positive half cycle, end A becomes positive. Now this is the A and this is the end B. This is the end B. Now, so as soon as the supply is coming out to be there, at a time only one signal will be positive and negative, and then there will be negative and positive. Now, so when the positive half cycle will become out to be there, so this will become a forward bias, and so it will conduct the signal. While for that part, this will become a reverse bias, it will not conduct. During the second half, so this part will not conduct, only this part of the. So at a time one diode will be conducting, but which will make output will be come out to be regular in nature. Now what kind of output will be there? So we will see that let us say this kind of graph we are going to draw. This is the input which we are going to supply like this way. Now this is the output for D1, this is the output for D2, and this is the combined output. Now for the first diode, the output will be like this way. Now this we can draw it out, and only one kind of output will be there for one kind of diode. For diode D1, so the output will be this and this and this, while for D2, during this signal the output will be there, and during this signal. So when we will combine the output, so output will become out to be this one. So this diode has got the output like this in nature, which is totally output in nature. Now the advantage of this rectifier is that the output and efficiency is very high, because AC supply delivers power during both the half cycle. Okay, because AC is going to supply both the cycle, but the disadvantage is that the output is small, because each diode utilizes only one half of the voltage, and the center has to be located properly, and so that a larger transformer is required. So that is the main problems with the full wave rectifier. So this is how diodes convert one wave of the signal to the other wave. So that is the part how the diodes are going to be used in application. But now the problem arises, one major problem which going to arise is that how to identify a diode. Identification of diode. Identification. How to identify a diode. When you are going to market to purchase a diode, how will you identify whether you have purchased a proper diode or not? So basically diodes, we know the symbol of this diode and we used to teach the symbol only. But practically the diode is looks like to be a cylindrical shape and having silver line at the one end. So when this silver line is being attached, so that indicates the N type. Or once you go to shop, you show this kind of that. This is basically black in color and this is silver in form. If you forget it out, you connect it with the multimeter, and during forward bias it will go minimum maximum current will flow and minimum resistance will be shown, and during reverse bias minimum maximum resistance will be shown and minimum current will flow through it. So this diode has some got rating 1N4001 to 4020 for PN diode. These last two digits indicates the operating voltage, that up to what volt the diodes can be get operated. So 1N the company name and 40 is the series for the diode which is being given. So once you identify all these things, you can able to get the complete identification of the diode. So this was the application identification of the PN diode. So next times we will switch on to transistors, amplifier and the oscillator. Thank you.